So today's topic will be the rainfall, rainwater drainage system. So we're talking about our system, which is called Rainplus, and it's a Cyphonic way to drainage the rainwater system. Because there are two kinds of system for the drainage of the rainwater. We can have the traditional system, which work with gravity, and we have a partial filling inside the pipes and the system in general. And then we have Sephonic system, called a full bore system, because we have a total filling of the pipes. Both the system are made up of main items, which are the roof outlet, the pipe runs, which are the pipe, and the bracketing accessories for the ends of the pipe to the structure of the building. Before going deeper inside the presentation, I would like to ask you a question. In the section on the right, when you can see the chat, there is also a pool section. Here you will see a question that you can also see on the screen. And this: in your many years of experience, have you ever heard about the Sephonic drainage system? You should see in the pool section, okay? So you can vote if you ever seen or heard about Sephonic drainage system. In this way, we can also understand the people we are talking to. Okay, I can see that there are some votes. We have a 50-50 situation. Half of the people knowing the Sephonic system and another half no. Okay, good to know. So this presentation will be useful for you. And okay, to understand a Sephonic system, let's start with a comparison between a traditional system and a Sephonic system. As you can see here, we have a building with a traditional and a Sephonic system. Starting from the roof, we have the roof outlet. As you can see, for a traditional system, we have a quite amount of outlet. In this case, we have 14 outlets for a traditional drainage system. And this outlet is a standard outlet, basically a funnel on the roof that allows the water to go inside our building. And there are no major feature in this outlet. It's basically a hole on the roof. For a Sephonic system, as you can see, we have less outlet. Okay, in this case, 9. And these outlets are special outlets designed by the producer, in this case by us, in order to achieve some performance and some major feature. In this case, we want to have the water to go straight inside the pipe in order to have a full bore system and not a partial filling like in a traditional system. If we go further, for example, for the main stack, in a traditional system, we have downpipe for each outlet that goes straight from the roof to the bottom of our building. Sometimes those stacks are embedded in the concrete pillar of our structure, so you can't go to maintain those pipes because are inside the main structure. For a Sephonic system, instead, you have a short piece of pipe below each outlet, okay, because we are going to collect them at the level of the roof. As a matter of fact, if we talk about the collectors, in a traditional system, those are mainly below the ground, and you have a slope, okay? So you're going to steal space. You have to go deeper inside the ground. For a Sephonic system, the pipe of the collector has no slope. It means that you can hang it at the level of the ceiling without going to steal any space inside your building. If you think about a warehouse, for example, where it is important to use all the space of your building, if you think about having a collector without a slope, you can imagine the advantages of not stealing any space that you can use for the warehouse. Then, if you talk about the performance, for a traditional system, we have a partial filling. It means that we have always a mix of air and water inside our system. And is the 30% in the vertical stack and 17% of filling ratio in the collectors. You can understand that we are not using all the space of our pipe. In a Sephonic system, instead, we are using the 100% of the space because we have a full bore system. We have only water inside the pipe. So we are using and maximize the performance of the diameter of our pipe. You can also see from the image that in a traditional system, we are forced to collect the water according to the position of the stack. But in a Cyphonic system, you can bring and put the stack wherever you want. In this way, you can also optimize the system according to your needs. If you need the vertical stack in a corner, you can put the vertical stack in a corner, and then using the collector, you can reach this point, and so on. In this way, you can also reuse the water if you want. So let's take a look about the Sephonic principle in general, because if in a conventional system, since we don't have a full bore situation, we have a mix of air and water. And this is happening because when the water starts to go inside the outlet, it starts to circulate and suck always air from outside. Okay, we have this vortex that characterizes the flow of the water, and so we have a partial filling of our pipes. But in a Sephonic system, thanks to the geometry of the outlet, we direction the water straight inside the pipe, avoiding the creation of the vortex. In this way, thanks to the anti-vortex plate, sooner or later we are going to have a complete full pipe of water. Thanks to this, and thanks to the full bore flow, we can apply mathematical models such as the Bernoulli Principle in order to understand the behavior of our system. Okay, and these models define the relationship between the velocity and the pressure that you have inside your system. And the engine of a Cyphonic system is this pressure, because we are going to create a negative pressure that sucks the water from the roof and it drains the water where we want. This thanks to the filling ratio, which is a total filling ratio. Thanks to the Bernoulli Principle, then, we can create a relationship between the eighth of the water on the roof during a rainfall event and the flow rate that we have inside our system. It means that even when the system is not working Sephonically, we can start to drain the water, okay? Because when it starts to rain, we have a few amount of water on the roof and the system is working by gravity. So we have the gravity flow stage. The water is going down in our pipe simply by the gravity, like in a traditional system. But when it starts to rain more, the level of the water on the roof increase. And we are going to touch the blue plate, which is the anti-vortex plate. And we stop the air to go inside. So we start to fill all the pipe, and we have the activation of the Sephonic effect. This activation of the Sephonic effect goes to sucks more water from the roof. So the level starts to decrease, and we start to put air again inside the system, and we stop the Sephonic effect. This activation and deactivation of the Sephonic effect is called plug flow stage. Then we increase again the rain, and we start to increase again the water height on the roof, and we almost always are above the blue plate. So we have a situation where the pipe is completely full of water, almost, beside for the presence of some bubbles. In this stage, we have the bubble flow stage. So we are working Cyphonically, but there are still the presence of bubbles inside our pipe. We are around the 60% of the maximum flow rate of our system. Then in the end, we reach the full bore flow stage. We reach the design flow rate of our system. So the system is always working Cyphonically. The pipe is completely full of water. We have the maximum flow rate. We have a really high speed in our system, and we can drain a lot of water. On this topic, we are going to see a video that is a video of a mock-up that we have here in our company. As you can see, this is a mock-up of a Cyphonic system where we are simulating the drainage of a 500 square meter roof. As you can see, this is the first stage, which is the gravity flow stage. The water is drained by gravity in a traditional way because we don't have a lot of water on the roof. Then when we start to rain more, we start also to increase the water on the roof, and we enter in the second stage, which is the plug flow stage. As you can see here, we have an increase of the velocity because we have the activation of the Sephonic effect, and then the system slows down again because we have the deactivation of the Sephonic effect. This is the plug flow stage. Then we enter in the bubble flow stage. As you can see, we have a really increase of the velocity, but with the presence of bubbles, okay? But the flow is really high, and so the velocity. The pipe is almost always full of water, but still there are some bubbles. And then finally, when we reach the maximum flow rate in our system, as you can see, there are only water, and the system is working with a high speed and a high velocity and the maximum flow rate in our system. Okay, so as we've seen in the video, the system is start to working not only when we have always water inside our pipe, but during the increase of the rain in a rainwater event, we can start to drain the water from our roof from the beginning. So we don't have the problem that some people may think of the system is working only when you have a lot of water. No, the system is working since the beginning, and it starts working through phases. So we start from a gravity phase, and then we have the activation of the Sephonic effect with the increase of the rainwater on the roof. The performance of the whole Sephonic system are depending on different kind of things. The first things is the type of pipe and fittings that you are using. And as was here, we are using for our Sephonic system the HDP pipe. We can reach a really high negative pressure of minus 800 millibar. Thanks to this, we can create this negative pressure to suck the water from the roof. The second thing is the Sephonic roof outlet, and we're going to talk about it in a couple of seconds. The third aspect is how you design and calculate the system. And as well, here we have an internal software called Rainplus that we use to design and develop the system. So if you have projects that you think that are suitable for a Sephonic system, you can get in touch with us and we can realize the project for you. So now we are going to talk about the Sephonic roof outlet performance, because we took something like 4 years of development to decide how to realize our outlet. And during this process, we decided to focus on 4 main aspects. The first one was to have a models that can be used on different roof construction. So we decided to develop only one outlet that can be installed on all the different kind of roof construction. For example, we have the outlet that can be installed on membranes roof with PVC or TPO or bitumen membrane. We have the outlet. But the same outlet can be installed also on metal gutters. So if you have a gutters that can be aluminum or stainless steel, we can install our outlet, and which is the same of the one before, also in metal gutter. But also directly on a concrete roof, the same outlet, because on the market there are different competitors that have different product for different application. But we as Valsir, we have only one product that can be installed on all the different type of roof construction that you have. Then we decide to focus on the performance of the outlet, and we decide to develop only one model up to 66 liters per second. Okay, so we have one model that can drain from 1 to 66 liters per second. This is important because on the market, there are competitors that have different models for short range of flow rate. For example, one model up to 6 liters per second, or another model up to 12 liters per second. or up to 25 liters per second, and so on. We as Valsir, we have only one model that can be used from 1 to 66. In this way, also for your project, we can decide to apply the outlet in all the situation that you have without having to decide which type of outlet, because we have one model that can be used for all different type of project. Do you want to see something, Michele? No? Okay.
I will keep it for the end of the presentation.
And so it's important because you can also you don't have a problem of the warehouse, because you have only one model to stock if you have a big project. So it's important, this aspect, because we can help you in the best way we can, because we have one model that can be applied in all the situation. The third aspect was to minimize the water rate for the activation of the Sephonic effect. Because in this way, since we wanted to minimize the water rate, we want also to reduce the water load on your building, okay? Because less water you have on the roof, it means that you have a less weight of water on the structure of your building. And in this way, we can see another chart. As you can see, this is the curve of the water demand of our outlet. According to the flow rate, we need some millimeters of water on the roof for the activation of the Sephonic effect. And if we compare the same competitor as before, we can see that we need always less water. It means that we are going to have the Sephonic effect sooner and with less water on the roof. So we are going to stress less the structure of your building. The last aspect is the safety, because we wanted to have an outlet intrinsically safe. What does it mean? Let's see this example. You can see that you have 3 outlets of 12 liters per second each, for a total of 36 liters per second for the system. If something happens of one outlet, we have a drop of the maximum flow rate. So we are losing 1/3 of the flow rate in our system. But our outlet, if you remember, has a range from 1 to 66 liters per second. It means that we can use the extra flow rate that every outlet has in order to drain all the water, because the outlet and the system automatically rebalance the flow rate inside in order to drain the flow rate that you lost because of a problem on the roof. And the problem of the roof can be something really simple. For example, a bag that it covers the outlet. You don't have control of this. So maybe a bag is covering one outlet and you're going to stress the system. But by using our outlet, you have a really wide range of flow rate. So the system can rebalance and drain again the water that you've lost because of the loss of one of the outlets. So this is the intrinsically safe of our outlet. It is important because sometimes, maybe by using a competitor outlet, you don't have this range because they have fixed flow rate with a short range. If you remember, there is one outlet up to 12. If something happens, you don't have the extra flow rate to add to the other outlet in order to drain a situation with a problem. And speaking about situation with problem, let's do a short focus about overflow system, emergency system. What is an emergency system? Let's see this example. We have a rainfall event. The water levels start to increase on our roof. The water is drained by our system, but then something happens, not on the system, but at the end. For example, in the main sewage or in the manhole when the system ends. So the problem is that the water can't be drained anymore from our roof. And so the water levels start to increase and you have a load on the structure of your building. And this can create a lot of problems. That's why you always have to think about an emergency system. In these cases, when you have a bad situation at the end of the system. So not on the system itself, but at the end. And you can do an emergency system in different ways. For example, can be basically in a hole for discharging the excess water from the roof, from the parapet. This is the simplest one. So basically you open a hole at the end of the parapet in order to drain the extra water. Or you can have a secondary conventional system, not Cyphonic. For example, if you have a renovation of an old building that you have already a traditional system installed, you can use the traditional system already installed as emergency and install a new Sephonic system as primary system. Or you can realize a secondary Sephonic system for the emergency. In this way, you can install an outlet with an extra height in order to drain the extra water when you have a problem and simply solve the problem. Let's go back to the example as before. We have a rainfall event and we start to drain the water from above. Then something happened at the end of the main system. But since we have an emergency system, the extra water is going to be drained by the secondary system, in this way Cyphonic. It's important, as you can see, that the end of the system are different. Otherwise, if we have a problem on the main sewage and both the system are going to be drained in the same main sewage, you can understand that having an emergency system is not so clever. As Vasir, to create the emergency system, we have an overflow kit. As you can see, it's basically a kit that can increase the height of the water from 35 up to 85 millimeters. Differently from some competitors on the market, by using our emergency kit, we are not going to decrease the performance of our outlet. It means that we can still drain from 1 to 66 liters per second, because sometimes it happens that when you install an emergency kit, you also decrease the performance of the outlet, but not in Vasir's case, because the outlet keeps the performance from the beginning, so from 1 to 66 liters per second. We are now going to see a little case study that Michele will present you in order to understand a little bit more the differences between a traditional and a Cyphonic system. Go ahead. Thank you, Michele.
Okay, thank you very much. I will show you a case study like we did last week with the VBF. This is a project of a warehouse in Korea. It's very, very useful to make you understand how the Cyphonic works and how can optimize your system. So here you have a warehouse with a pitched roof with an area of 2,000 square meters. The rainfall intensity is 180 millimeters per hour, so quite standard. And the pitched roof is divided in two pitches with 50 liters for every pitch. So it's very, very easy project to understand, also with easy numbers, and can easily explain the difference. So Paolo, please. Fortunately, when we arrived in Korea to the designer, to the Hyundai designer, they had already prepared a 3D design for the conventional system. So as you can see, they provided 10 outlets with 10 stacks of 110 millimeters and with collectors with a diameter that was going from 160 to 315 millimeters. So I try to I show you the 3D that we realized for this Cyphonic system, for this conventional system, and I invite you to reflect, to think about this system. First of all, you see that you have 10 risers, so more interference with the structure. Then you have a collector. You are forced to put the collector underground. So try to imagine with the big diameter the cost that you have with the digging of the cost of digging to create the space for this collector that must have a slope, because the collector in conventional system must have a slope. So lot of space wasted, lot of money wasted in operation that with Cyphonic are not required. But now let's see what we did in Cyphonic. So first of all, we reduced from 10 to 6 outlets. So exactly the 40% less of outlets. Then you have lateral collectors with very, very smaller diameters if you compare to the diameter that they had in a conventional system. So in the conventional system, they went from 160 to 315. Here you go from 90 to 200, so completely different. And you see only one vertical stack with a diameter that, of course, is larger than the conventional ones, but is only one. And something that I want to point out when I show you the 3D that we prepared is that the system is totally and fully custom fit, as they say for the clothes, because you can put the riser in the place that you prefer. You can put the riser wherever you want, because since you don't have any slope in the horizontal collector, as you can see, you can orient, you can adjust the system according to the real need of the client. And even if you're staying in the ceiling, you're not wasting space, because being no slope is totally flat, so you are not stealing space to the customer. You don't have to dig, so you're reducing the cost also from this point of view. But let's see a chart that I want to. There is a chart that I want to show you, because there is another advantage that at the very beginning we did not consider, but we started to discuss last week, speaking about VBF, and this COVID and safety and time in the building site. So basically, according to what you explained me last week, because of COVID pandemic, you are not allowed to stay every day in the building site with all the workers that you want. So you have to reduce the people in the building site, and you have to reduce the time in the building site. So if you see the comparison, you see that first of all, you have less outlets to install, 6 instead of 10. So the 40% less of outlet. Second, see the diameters. The maximum diameter that you have with Rainplus instead of a conventional is the 200. So also the movimentation of the material is easier and faster, so you can optimize your time in the building site. But then I want to point out the most important figures and numbers that we have speaking about COVID pandemic. And this is the quantity of material that you need to realize the Rainplus system, the Cyphonic system. You see that you have 75 instead of 175. So less than the half of the pipes and 2/3 of the fitting. So you reduce the quantity of pipes of fitting. So you reduce the quantity of welding, and you reduce the quantity of time that is needed for the installation in the building site. And this is important, because if your time in the building site is limited, you are not allowed to stay in the building site when you want and how much time you want. And you have also to be careful about the safety of your workers. You have less material to touch, you have less material to install, is needed less people to install it, because it's easier to move because of the smaller diameter, and there is less material to assemble, so it's also faster. So I want to show you also this side of the Cyphonic system, beside what Paolo said, because it's very, very important. It's very, very efficient, and is going to give you an advantage, a real concrete advantage, first of all because of safety, and second because it's something that is helping you in creating business, because since you are limited, you can manage more building site and you can increase your business because you are faster. So now I let Paolo to conclude the presentation. Then I see that we are having the first question from Mr. Gutierrez, which is always very, very active. And
Okay.
we will leave you free to speak with us.
Okay, thank you, Michele, for the case study. So we will do a final recap of the Sephonic system in general, and we look at the main advantages again. So you have economical advantages because you have, as mentioned by Michele, a lower amount of roof outlet to install, a reduction of the size of the pipe, so a reduction of the diameters, the maximum diameters, also of the cost of the pipe itself, a less quantity of stack. It means a less quantity of pipes and fitting to install. And as Michele mentioned, is really important in this period because you have to pay attention about the number of people that you're going to use on the building site. So having less quantity of material to install is important. Then you have a space saving advantages because the horizontal pipe has no slopes, so you can install it at the level of the roof without losing any space of the building inside. Okay, and the down pipe can be installed wherever you want at the building perimeter, so you can decide and customize the system according to the client's need. You want the stack in the corner, you can put the stack in the corner, and we'll bring the water to that point with the collector at the level of the roof without losing any space. You have high performance compared to a traditional system because the system is a full bore flow. We are using all the space of the pipe, so we are maximize the flow rate of our system. You have a night velocity of the flow. It means that you can drain the water from your roof sooner and avoid so problem if you start to have more water on the roof surface. And it's also a self-cleaning system because thanks to the velocity and the speed that you have inside the pipes, you can also clean them by the dirt, the dust that you have inside, maybe because it's not raining from some month, then it starts to rain. Okay, the system has some dirt inside, but thanks to the speed and the velocity, you're going to clean all the pipe. In a traditional system, since you have a really slow flow, also because the slope sometimes is not so high, you start to have a lot of dirt in the collector. And cleaning them, it means that you have to dismantle and destroy your building because you have to dig up the pipes. But in a Cyphonic system, you don't have this kind of problem because it's a self-cleaning system. And also is eco-compatible because you can bring the water where you want, and you can also reuse the water if you want, because maybe you can collect the rainwater in some tank and then reuse it for other purposes. So it's also a green system. We are now going to see a couple of references all around the world of where we install our system. As you can see, this is a factory of the Continental for the tire factory, and we installed the Sephonic system on their factory. But also Bridgestone in Pune, India, where we installed on their factory our Sephonic system, both the primary and the emergency system, as you can see in this big concrete gutter. Then you can see we install our Sephonic system in this Genstab auto components factory for the automotive for an automotive factory in China, when we install in their big factory our Sephonic system. But not only big surfaces building, but also tower. We install our Sephonic system in the Prima Per tower. If you remember from last Thursday, we install also the ventilation branch fitting in this tower. So we install our system in this tower, not only the ventilation branch fitting, but also the Cyphonic system for the drainage of the rainwater of a tower. Or, as already seen in the beginning of the presentation, the Kia store in Sydney. On this big roof surface, we install our Rainplus system to the drainage of this building. But you can understand the difficulties of this type of building because it's really wide. So you have to drain the water from the middle. And the Cyphonic system is the best solution and application for this type of building because you can ensure that you can drain the water in the middle of the roof surface without having to create a lot of slope. Also, this IKEA in China, which is not a factory but a logistics center with a really high surface. Another tower here in Australia, where we install our Sephonic system, also thanks to our BIM families for Revit, because we supply to the designer also the Revit models for their project, because we have the complete range of families also for the Rainplus system. Or another factory here, the Renault factory in Slovenia, as you can see, is really big. The surface is really wide, same as this logistics center in Shanghai, China. So you can understand that you can maximize the performance of a Sephonic system in this type of building. So when you have a lot of surface to drain. Thank you for your attention.